here we're going to look at the trigonometric ratios, talking specifically about the big three ratios that we all know, sine, cosine, and tangent, and the minor three ratios that go with them, cosecant, secant, and cotangent. Okay. Now all of these trig ratios are related to the classic right triangle. So when we're talking about a right triangle, there's a few things that we have to know. First, your triangle angles are labeled with capital letters. So for example, in this triangle here, we would label our sides, say for, A, maybe B, and C. Now the other thing that we know is that the one angle or the one side has to be a right angle. That's what makes this work. The second thing that we have is that your sides are labeled with lowercase letters. Now when we're looking at our triangle, we look at the angle we have, and the side opposite that angle gets labeled with the lowercase of the angle letter. So this would be side A, down here would be side B, and over here would be side C. Now the other piece that we have is we have the trig labels, or what helps us label our trig. So for example, if we were to say that angle A was our angle, then in order to do our trig we have a couple of ideas. First, we have the side opposite our angle we call opposite. Then we have the side next to our angle we call adjacent. And that makes the long side that classic hypotenuse. Now we use those measures in order to help us. So when we are talking about our ratios, so for example, let's look at sine. Well, sine of our angle is going to be opposite over hypotenuse. So if A is my angle, then in order to find the sine of my angle, I'm looking at the value of my opposite, so this side A, over my hypotenuse, the big side here. Okay. Your cosine would be the same, adjacent over hypotenuse, so that would be your adjacent side here over the long side, and then tangent is opposite over adjacent. So opposite over adjacent. And that becomes true regardless of how you do it. If we were to say that B was our angle, then the side opposite B, this would become opposite, the one next to it becomes adjacent, and the long side stays as your hypotenuse. So it doesn't matter where your angle is, you can always find your trig function. Now with that, we have what are called the three minor functions. We have cosecant, we have secant, and we have cotangent. Cosecant is the reciprocal of sine. Okay, so when we're looking at that, our cosecant down here is the reciprocal of sine. My secant is the reciprocal of cosine, and my cotangent is the reciprocal of tangent, which is why their fractions are just the exact opposites of what we have. Okay, so we have the major three, which are the main ones, and then we have their reciprocals, okay, which are the minors. Now, as always, because we're dealing with right triangles, the Pythagoreans Theorem is always going to come into play, and we will use Pythagoreans Theorem to find any potential missing sides that we may have. Okay. Now, with this, as long as you know or have the capability to know one of your trig ratios, you will always then be able to extrapolate out and find the other five. Okay. So in these examples, we are going to be looking at essentially how to take the triangle information given and find the trig ratios that match that triangle. So here we're giving you a triangle. We've labeled this upper angle as beta, and then we've labeled the sides. So my right triangle fits here. And one thing that you can do to try and help is you can always label your sides according to the angle provided. So in this case, we know that this would be your opposite, and we know that this side would be the adjacent. Obviously, the long side is always your hypotenuse. So essentially, all we're asked to do here is find the 6 trig functions that are related to this triangle. So you always want to start with the major ones or the easy ones we know. So we know that the sine of my beta is going to be opposite over hypotenuse. So this is going to be 3 square roots of 3 all over 6. Now the biggest thing you have to remember here is you must always reduce. So in this case, 3 over 6 will reduce down, and we get that the sine of your beta is going to be the square root of 3 over 2. Now let's look at the next one. We have the cosine of beta. So that's going to be adjacent over hypotenuse. So this is going to be 3 over 6, which again is going to reduce itself down to 1/2. Then we have the tangent of my beta, which is going to be opposite over adjacent. So 3 square roots of 3 over 3, which is going to reduce itself to the square root of 3. Now, after you find these major 3, there are 2 things that we could do. One, you could continue to use the triangle to find its others, or you can use the idea of the reciprocal. Okay, either one works. It's going to get you the same result. So let's go ahead and look at the cosecant of beta. Well, one thing we know about the cosecant of beta is that the cosecant of beta is the same as 1 over the sine of beta. So I'm going to show you how to use the triangle to find it, and then we're going to look at how to use the sine to find it. And then it's your choice on what method you like the best or how you wish to approach your trigs. So if I'm going to use the triangle, so let's go ahead and we're going to use my right triangle here. Using the triangle says that we have to remember the cosecant is going to be the same. So my cosecant of beta is going to be the same as my hypotenuse over opposite. Essentially, we are flipping the script. So my hypotenuse is 6, so this would end up being 6 over the opposite is 3 square roots of 3. Now just like before, we have to reduce. So in this case, my 6 over 3 square roots of 3 would become 2 over the square root of 3. And now you must rationalize. To remember to rationalize says that we have to multiply both the top and the bottom by your radical, thus removing the radical from the equation. And in this case, we end up getting 2 square roots of 3 all over 3. Notice the radical is no longer in the denominator here, and so therefore you would be able to say that you are good to go. Sorry, I lost my words. Now, what if I wanted to use, instead, I wanted to use the reciprocal, so 1 over the sine of beta. So in order to do that, we would say that your cosecant of beta is the same as 1 over the sine of beta, which is the same as 1 over, and then if you remember, my sine was the square root of 3 over 2. So this would be the square root of 3 over 2. Well, your fraction rules say you're going to keep the top and multiply by the reciprocal of the bottom. So this then becomes 1 times 2 over the square root of 3, which is going to give me 2 square roots of 3 over 3. So you can see in both of these you came up with the same answer, but they both had a different approach. Okay, so either approach is going to work. It just depends on what it is you want to do. Now we also have to find your secant of beta, which if you remember is 1 over the cosine. So in this case, your cosine is adjacent over hypotenuse, so your secant would be hypotenuse over adjacent, so this would be 6 over 3, which equals 2. Again, if we use the reciprocal here, it would be 1 over 3 over 6. Reduce that down, and you still end up with 2. Okay. Now the last one we have is the cotangent of beta. Again, is the same as 1 over the tangent of beta, which in this case, my tangent is opposite over adjacent, so the cotangent is adjacent over opposite. So we would have 3 square roots of 3, or 3 over 3 square roots of 3. So here we go. And in this case, my 3 over 3 would cancel or reduce, so this becomes 1 over the square root of 3, which when we rationalize becomes the square root of 3 over 3. And thus we have found all 6 pieces. Now another way that you could see this is without an actual triangle. So you're given a function and you're asked to find the other 5. So in this, what you would actually do here is you would have to create your triangle. So I highly suggest whenever you're given this situation, you always draw out your triangle so that you can really see what it is that you are doing. You need to label one of your triangles as your angle, and then you have to look at what it is that you have been given here. Well, in this case, 0.7, well, this is going to be the same thing as 7 over 10. And if you remember, your cosine is the same as adjacent over hypotenuse. So in this case, my adjacent side would be 7. So that would be this side over here. My hypotenuse would be 10. And that leaves this side as my missing side. Now this is where Pythagoreans Theorem comes into play. So again, a squared plus b squared equals c squared, and we can find our missing side. So here we'll have x squared plus 7 squared is equal to 10 squared. So here we would end up with x squared being 100 minus 49. So x is equal to the square root of 51. Now once you know your missing side, you can find your other sine function, or your other trig functions. So here we would know that the sine of my beta, or the sine of my theta, whatever you want to call it, is going to be opposite, so square root of 51 over hypotenuse, which is 10. My tangent is going to be opposite, so the square root of 51 over adjacent, which is 7. Now I have to do the other 3. So in this case, I would have my cosecant, which is going to be the reciprocal here. So this is 10 square roots of 51 over 51. So how did I get that? You flip the reciprocal of your sine function and then rationalize your denominator. Here we would have the secant, and in this case again it's going to be the reciprocal of your cosine. So this, in this particular situation, would be 10 over 7. The last thing that we have is the cotangent, which is the reciprocal of tangent here. So again, it's going to be 7 square roots of 51 over 51. Alright, let's try it one more time. So here my secant, again, I have to remember that secant is going to be hypotenuse over adjacent, which is going to equal the square root of 17 over 1. So I can make myself another triangle. And I can put in my angle. And in this case, my hypotenuse here would be the square root of 17. My adjacent would be 1. And this opposite is what I'm looking for. So in this case, I would have 1 squared plus x squared is equal to the square root of 17 squared. So x squared is equal to 16, so x equals 4. Now I've been given the secant, so the first one I would start with is the sine of my angle, which is going to be 4 over the square root of 17. Remember, you always need to rationalize, so 4 square roots of 17 over 17. My cosine is going to be 1 over the square root of 17. Again, we're going to rationalize. So we've got the square root of 17 over 17. My tangent is going to be 4 over 1, which you could also just simply write as 4. Now the other two that are missing is my cosecant. My cosecant is going to be the opposite of my sine. So if we look at the original sine, the opposite of that is going to be square root of 17 over 4. And my cotangent is going to be the opposite of tangent, so 1 over 4. And there you have it. Everything that you would need to know to get started working with trig functions and being able to take either a given triangle or a given trig function and find all 6 of the known trig functions that we are using. Okay? So a few things to remember. 1, always draw your triangle even if it seems like extra work or unnecessary, because it really does help to lay out and organize your thoughts. It also helps you to avoid making mistakes. 2, always make sure you reduce your fractions as far as they can go. And 3, you always need to make sure that you rationalize everything you do. Remember, rationalizing generally means you do not leave the radical in your denominator. Alright, so if you have any questions, please let me know. Otherwise, I do hope you enjoyed yourself. I hope this helps in your efforts of learning trig functions, and I look forward to speaking with you next time.